welcome back to our YouTube channel. Today we are going to discuss the fundamental identities.
But let me present first our topic objectives. So our topic objective is to define and use the fundamental trigonometric identities. And these trigonometries are reciprocal identities, quotient identities, Pythagorean identities, co-function identities, and even and odd function.
Reciprocal identities. Reciprocal identities are the reciprocal of the six main trigonometric functions, namely sine, cosine, tangent, cotangent, secant, and cosecant. And it plays a fundamental role in trigonometry and are essential for solving a wide range of mathematical problems. Each trigonometric function has a corresponding reciprocal function. Specifically, the sine function is the reciprocal of cosecant function, and vice versa. The cosine function is the reciprocal of the secant function, and vice versa. And lastly, the cotangent function is the reciprocal of tangent function, and vice versa.
For example, find the cosecant 30 and cotangent 45, whereas the given are sine 30 is equal to 1 half and tan 45 is equal to 1. So to find the reciprocal of cosecant, we must use its reciprocal identity, which is 1 over sine. Therefore, cosecant 30 is equal to 1 over sine 30. Then substitute the value of sine 30 and then simplify. Therefore, the value of cosecant 30 is 2. Now, to find the value of cotangent, we must use its reciprocal identity, which is 1 over tangent. So, cotangent 45 is equal to 1 over tangent 45. And then substitute the value of tangent 45, then divide or simplify. Therefore, the value of the reciprocal of cotangent 45 is 1.
Quotient identities. Quotient identities define the relations for tangent and cotangent in terms of sine and cosine. Now let's consider sine, cosine, and tangent functions. If we define this function in a right triangle, we have the following, where O is the side opposite to the angle, A is the side adjacent to the angle, and H is the hypotenuse of the triangle. Given these definitions, we can show that tan theta is equal to sine theta over cosine theta, as long as cosine theta is not equal to 0. Now that we have verified that we can write the tangent function as the sine of the angle divided by the cosine, and since cotangent is the reciprocal identity for tangent, we can write the cotangent as the cosine of the angle divided by the sine. Therefore, we have the two quotient identities.
So for example, use the quotient identity to solve for the value of cotangent 60. So the quotient identity or the quotient formula for cotangent is cotangent equal cosine over sine. So cotangent 60 is equal to cosine 60 over sine 60. Next is to substitute the value of cosine 60 and sine 60. Next is to simplify. Since the denominator is in the radical sign, as a note in the quotient identity, we must rationalize. Therefore, cotangent 60 is equal to square root of 3 over 3.
Pythagorean identities. Pythagorean identities are important identities in trigonometry that are derived from the Pythagorean theorem. This identity gives the relation between sine and cosine and are used in solving many trigonometric problems where one of the trigonometric ratio is given and the other ratios are to be found. So using the Pythagorean theorem in this diagram, you can see that x squared plus y squared is equal to 1. But also remember that in unit circle, x is equal to cosine theta and y is equal to sine theta. By substituting this, it gives us the first identity, which is the sine squared theta plus cosine squared theta is equal to 1. Thus, the first identity is derived, and to obtain the other identities, we divide both sides of the first identity by sine squared theta and cosine squared theta respectively. Thus, the three identities are obtained.
For example, given that sine 45 is square root of 2 over 2, find the cosine 45 using the Pythagorean identity. So, cosine squared 45 plus cosine squared 45 is equal to 1. So this is the Pythagorean identity that we will use, and then substitute the value of sine 45. And then square the square root of 2 over 2. Then that will result to the next step is to addition property of equality and then add negative 2 over 4. One next is to square root. Then we must rationalize because the denominator is in the radical form. Therefore, the value of cosine 45 using the Pythagorean identity is square root of 2 over 2.
Co-function identities. Co-function identities are trigonometric identities that shows a relationship between complementary angles and trigonometric function. Now, what is complementary angle? Two angles are classified as complementary angle if their sum is equals to 90 degrees. And we can write the co-function identities in terms of radians and degrees, as these are the two units of angle measurement. Now, these are the co-function identities in terms of radians and degrees.
For example, find cosine 60 degree and cotangent pi over 4 using the co-function identity. First is to rewrite the cosine 60 as cos 90 degrees minus theta, where theta is the complementary angle of the given angle. Then substitute. Then use co-function identity. Therefore, the co-function identity of cosine 60 degrees is sine 30 degrees. As for the cotangent pi over 4, we will be using the same process but not in degree, rather in radian. So first, we rewrite the cotangent as 9 pi over 2 minus theta, where theta is the complementary angle of the given angle. Next is to substitute. Then use the co-function identity. Therefore, the co-function of cotangent pi over 4 is tangent pi over 4.
Even and odd functions. Even and odd functions. So in this section, we will segregate the trigonometric function as even and odd functions. We have 6 trigonometric ratios, namely sine, cosine, tangent, cotangent, secant, and cosecant. These trigonometric ratios give the positive values in different quadrants for various measures of angle. For example, in the quadrant 1, in the first quadrant, where x and y coordinates are all positive, all 6 trigonometric ratios have positive values. In the second quadrant, only the sine and cosecant are positive, while in the third quadrant, only the cotangent and tangent are positive. In the fourth quadrant, only the cosine and secant are positive.
For examples, find the cotangent negative 30 and cosine negative 45. So the first one is we use odd identity. The next is to evaluate this. Therefore, the cotangent negative 30 is equal to negative square root of 3. The same process as, so for the cosine negative 45, we will use even function. Next is to evaluate this. Therefore, cosine negative 45 is equal to square root of 2 over 2. And that concludes our topic. See you next